So here we're looking at polynomial inequalities of degree 2 or higher. So you've dealt with inequalities before. I believe maybe we saw it a little bit at the beginning of this year, but you've definitely done inequalities when you took Algebra 1 or Algebra 2. So first example here, I want you to solve this inequality, and then I want you to graph the solution on the number line. So I want you to do that by yourself. You should know how to do that, hopefully. If not, then just follow the instructions once I explain it. But try to do this on your own, so pause the video, do that, unpause when you're ready to check your work. Okay, so solving this inequality, we add 5 to both sides, so I get 3x is less than or equal to 7. Divide by 3, x is less than or equal to 7/3. So this is my solution. So notice that is a set of numbers. We could write this in inequality or in interval notation, which we're going to need to recall, and it would be negative infinity, comma 7/3. So remember, we did this at the very first unit of the year, and then it followed us along throughout every unit of the year. And then I can graph this on the number line. So I put a bracket at 7/3 because I am including the 7/3. Remember, that's what the bracket means. Parenthesis means we do not include a number. Mark 7/3, and then I shade to the left because I'm including everything to the left of that. So your solution to an inequality is an interval of numbers. In this case, it's in most cases, if it's an interval, it's going to be an infinitely large interval. But there's a range of numbers that solve this or that satisfy this inequality. We want to keep that in mind as we're doing these problems. Okay, next one. This is just a little review of solving the different types of equations, because again, this can come up in this section as well. So here again, I want you to just pause the video, solve this equation, find all the solutions, unpause when you're ready to check your work. Okay, so we get x equals plus or minus 3i and x equals plus or minus 2. We knew that we should get 4 solutions because of our fundamental theorem of algebra, and this was a 4th degree polynomial. I can factor this, so I brought the 36 over. It factors in x squared plus 9, x squared minus 4, because what multiplies to negative 36 and adds to positive 5. Set each factor equal to 0, and solve. Notice that 2 of my solutions are complex, 2 of them are real. We're going to want to pay attention to that as well in this section. So now let's look at solving actual polynomial inequalities. So on your packet you can see the steps. I've conveniently put them there for you so you do not have to write them, but you need to understand what they mean. So first we're going to find what we call the critical numbers. So we're going to be using this example to go through these steps. What do I mean by critical numbers? Critical numbers are real zeros of the polynomial. So this is an inequality, but I'm going to treat it as if it was just x squared plus 2x equals 3. And I'm going to solve this equation. That is going to give me what I call my critical numbers. So x squared plus 2x minus 3 equals 0. X plus 3, x minus 1 equals 0. X plus 3 equals 0, x minus 1 equals 0, so I end up with x equals negative 3 and x equals 1. Those are my critical numbers. Okay, good. What do I do with them? Why are they called critical? Is it an emergency? Not exactly. So, next step, create test intervals using the critical numbers. So what does that mean? Well, if I look back at this polynomial, remember we talked about the domain of every polynomial is all real numbers. So I'm going to use the entire domain, but I'm going to separate the intervals with the critical numbers. So the domain is going to start at negative infinity, and then the lowest critical number is negative 3. Now, this was a greater than. Therefore, I am not including the values. So this is going to be a parenthesis, and that's a parenthesis. Now I continue, start the next interval at negative 3, and I go to the next critical value, 1. Close that with a parenthesis again because I'm not including the values. Start the next interval at 1, and go to positive infinity. So these are my test intervals. Notice we are using interval notation. It's very important that we understand interval notation. It always goes from lowest to highest. Parentheses means you do not include the number. A bracket would mean you include the number. Next step. Now I'm going to choose values to test within each interval. Pick numbers that are easy to work with. Okay, so what does this mean? It means I want to pick any number that falls within this interval. So the easiest number for me to pick would be -4. -4 is between -infinity and -3. Now I want to pick a number that's between -3 and 1. The easiest number to pick is 0. Now I want to pick a number that's between 1 and infinity. The easiest number to pick would be 2. Okay, so now what are we doing with these numbers? We're actually going to test them in the original inequality. And what we're looking for is, does it make the inequality true? So my inequality is x squared plus 2x is greater than 3. But I'm going to plug in a -4. So if I do -4 squared plus 2 times -4, is this greater than 3? So that's what I'm asking myself. So -4 squared, this is 16, this is -8, so I end up with 8 is greater than 3. This is true. So I know this interval is going to be one of my solutions. Now let's try 0. Hopefully you can do 0 in your head, but I'll write it down. 0 squared plus 2 times 0 greater than 3. Well, this is just 0 is greater than 3. That is not true. So this is not a solution. Now let's try 2. So we'll do 2 squared plus 2 times 2 is greater than 3. This is the question that we're asking. 2 squared, this becomes 4, plus 4, which is 8, is greater than 3. So that's good. That is true. So this is one of my solutions. So now the last step, just rewrite your solution intervals. So we're going to have -infinity to -3 and 1 to infinity. That is our solutions, and those are the steps to solve. Now, I didn't ask you to on this problem, but if we wanted to, we could also graph this solution on the number line. So we'll be doing that a lot. So we draw our number line, put a parenthesis at -3, and I shade to the left. I put a parenthesis at 1, and I shade to the right. Lovely. Alright, so I want you to try this on your own. So solve and graph. X squared minus 6x plus 9 is less than 16. So because I know you took good notes on the last one, and I already had written down the steps for you, you should be able to do this relatively easily. Pause the video, try to solve, and graph. Unpause when you're ready to check your work. Alright, so here we should end up with a solution of the interval -1 to 7, not including the -1 or the 7. And here's what we would graph on the number line from -1 to 7. Okay, next one. So we have x cubed plus 2x squared minus 4x minus 8 is less than or equal to 0. So I want you to go ahead and try and solve this and graph this on your own. I will give you a hint if you're stuck on solving it. Factor by grouping. Okay, so pause the video, find the critical values, set up your test intervals, test your test intervals, write your solution, and then graph your solution. Pause now. Okay, so here we should end up with a solution interval of -infinity to 2 with a bracket on the 2 because we're including it. So our solution graph should have a bracket at 2 and then shade to the left. How do we come up with that? So this one's a little bit tricky. The process isn't, but the result is. So factor by grouping. That's what I told you. I can take out an x squared from the first group, and I can take out a negative 4 from the second group. And then I'm left with x squared minus 4 times x plus 2 equals 0. Set each of these equal to 0, and I get x equals plus or minus 2 and x equals negative 2. So notice that there's repetition in one of my critical values. I don't need to write it twice, but it is helpful to recognize that. So now when setting up my test intervals, I'm going to go from negative infinity to negative 2. I have a bracket on the negative 2 because this was a less than or equal to. Then I go from negative 2 to 2. Again, brackets on the negative 2 and the 2 because we have an equal to. And then I go from 2 to infinity. Bracket on the 2, parenthesis on the infinity. So now I chose values in each test interval. I chose negative 3 for this, 0 for the middle interval, and 3 for the far right. So when I plug in negative 3, I end up with negative 5 is less than or equal to 0. That is a true statement. So this interval is one of my solutions. When I plug in 0, I end up with negative 8 is less than or equal to 0. That is also a true statement. Therefore, this is also one of my solutions. When I plug in positive 3, I end up with 25 is less than or equal to 0. That is not true. 25 is not less than or equal to 0. Therefore, this is not a solution. Now, the trick to this problem is we do not have two unique solutions. Because these both go to negative 2 and include the negative 2, we can combine those intervals, and that's why the solution interval is negative infinity to positive 2. So it's only because these are brackets. If those were parentheses, we would write each of these intervals independently. So if I gave you this exact same problem, but this was just a less than, your answer would be negative infinity to negative 2, and negative 2 to 2 with parentheses separating all of the values. But since it was brackets, we can combine them, and we get one solution interval. Next one. Also last one. So, I want you to solve a graph. X to the fourth minus 12x squared is greater than or equal to negative 27. Pause the video, do this, unpause when you're ready to check your work. Okay, so here we should end up with the solution intervals of negative infinity to negative 3, including the negative 3, so that's a bracket, negative root 3 to root 3, including both of those, so those are both brackets, and 3 to infinity, bracket on the 3. So our graph looks like this. Remember, the graph just really mimics the intervals. Now, how do we come up with that? Okay, so I added 27, set this equal to 0, factored x squared minus 9, x squared minus 3. I get x equals plus or minus 3 and x equals plus or minus root 3. Those are my critical numbers. So I have 5 test intervals. So negative infinity to negative 3, negative 3 to negative root 3, negative root 3 to root 3, root 3 to 3, 3 to infinity. Brackets on all of the critical values because this was a greater than or equal to, so we include the value. Now, pick a number within each interval. Again, pick something that's nice. So negative 4 is pretty easy to work with. Root 3, or in this case negative root 3, is negative 1 point something. So pick an integer. Negative 2. That works well. 0 is between negative root 3 and root 3. 2 is between root 3 and 3. And 4 is between root 3, or 3 and infinity. Plugged all of those in, test them out. The first one works because 64 is greater than or equal to negative 27. So that is true. Negative 32 is not greater than or equal to negative 27. So this one is false. 0 is greater than or equal to negative 27. So this is true. Negative 32 is not greater than or equal to negative 27. So this is false. And then the last one again is true. 64 is greater than or equal to negative 27. Okay, so quickly I want to go back to this example again just to show you how this relates to an actual polynomial, because that's what we've been doing as well. So I put this function into my calculator as a polynomial. So I ignored the inequality. And now if I graph this, remember the inequality is where is it less than or equal to 0. Here is where it's less than or equal to 0. So that's from negative infinity to positive 2. And again, that was our solution. So we can relate this to the polynomials and the zeros that we've been doing. So Here is your process. Find the critical numbers, determine test intervals, choose values, and write the solution.